Hi guys, in this video I want to talk about some examples involving the composition of trig function and its inverse function. So guys, the first one is the cosine of the cosine inverse of radical 3 over 2. So guys, we already know that the cosine and the cosine inverse kind of behind the scenes cancel each other out, and I will be only left with radical 3 over 2, which is based on the basic definition that we talked about in my previous video. But guys, we cannot just directly say that this equals to radical 3 over 2. We have to make sure that it satisfies the one of the basic conditions, which is that this value has to be in the domain of the cosine inverse, right? So before we answer this question, guys, we have to first make sure that this and this is they are the inverses of each other, which is the case in this for this particular example. But then we also have to make sure that, so we have to answer this question: is radical 3 over 2 in the domain of what? In the domain of cosine inverse, right? That is the condition that it has to satisfy. Guys, the domain for the cosine inverse, the domain of the cosine inverse is -1 to 1. Obviously, radical 3 over 2, if you simplify this using a calculator or otherwise, you know that it lies between -1 and 1. That means this guy is going to be just simply radical 3 over 2. Okay, so that was pretty simple. All you have to do is you have to verify two things. One, are these inverses of each other? Yes, they are. And then does this number lie in the domain of the cosine inverse? It does as well, so it satisfies both conditions. So the final answer is just radical 3 over 2. Number 2, I have a sine of sine inverse of 3.5, and we want to find the value of this. Now, first of all, sine and sine inverse, they are inverses of each other, which is good, so it satisfies one of those conditions. But then, guys, we have to ask ourselves, does 3.5 lie in the domain of sine inverse? Again, the domain of sine inverse is between -1 and 1. Guys, 3.5 obviously does not lie in that domain. What does that mean? That means we cannot just cancel these out, or they will not just cancel each other out and give us 3.5 as an output. No, that's not going to happen here, because this 3.5 does not lie in the domain of sine inverse. So what can we say about the answer here, guys? What we can say here is that it does not exist. It does not exist. So does not exist. We cannot find the value of this composition. Okay, so there is going to be examples where we cannot find the value for a composition, and we have to just make sure and verify whether that number lies in the domain of that particular inverse function. Now, the third one I want to show in this example, and then I will show the rest of them in my other video. Guys, I have something slightly different, and I would like to show you how to handle these types. So now I have sine of tan inverse of -1. Okay, now guys, first of all, these are not inverses of each other. Here I have a sine function, here is a completely different tan inverse function. So they cannot just cross each other out, and we cannot just get an output right away. We cannot get the answer right away. So then if we have something like this where these are not inverses of each other, we cannot say that there's no value for this composition. Guys, what we have to do is then we just kind of break it down, and we kind of look at this inner expression. So inner expression is tan inverse -1. Guys, in my previous videos, I have already explained, and I have already gone through some examples how to calculate the inverses of different trig functions. So in this case, again, this is something that we have already learned in my previous videos. So if you already know and you have watched those videos, then you can easily do it here. Or if you have not, then please go back and visit that video, and then you should come back to this one. But here I'm quickly going to illustrate, or I'm going to show you how to actually do that. Guys, to evaluate this, there's few things one has to keep in mind. For me, the easiest way is to kind of remember, first remind myself that the range for the tan inverse function is between -pi/2 to +pi/2, right? And these empty circles tell me that it does not touch the endpoints, right? Now, since there's a -1 here, that also tells me that the value for this is not going to be in the first quadrant, because in the first quadrant all the trig functions are positive. So it is going to be in somewhere in the fourth quadrant, right? It's going to be in the fourth quadrant. So I don't even have to worry about this, right? I don't have to worry about the first quadrant. So looking at the fourth quadrant, now I'm going to look at my unit circle. So from my unit circle, guys, again, what I want that angle here. This is supposed to be an angle. I want that angle for which the tangent of theta is -1, because that is exactly what this transforms into. We want to find that theta, right, for which the tangent of theta is -1. Obviously, it cannot be in the first quadrant, and we only have two options to choose from, first and the fourth quadrant. So it cannot be in the first quadrant because it's a negative number. It has to be in the fourth quadrant. Again, guys, it is not directly provided to us in the fourth quadrant because these unit circle only provides us sine and cosine values. But we know tangent is the ratio of the sine over cosine. So looking at the fourth quadrant, guys, to get a -1, basically we know that tangent is the sine over cosine, sine over cosine. So the only way we can get a -1 if we are dividing two quantities is like if both the quantities are basically the same and one of them is a negative of the other, right? If one is positive, one is negative, and have the same, basically same magnitude, they will just cross out, leaving us with only -1. And guys, it is not too difficult to see that from the unit circle. The only value that satisfies that condition is when theta is -45 degrees or -pi/4 radians, because for that x and y are basically have the same magnitude, different signs. So this angle right here, 45, the coordinates are -45, okay, because we are going, this way we count positive angles, this is going counterclockwise, and guys, this is clockwise, means clockwise means we count negatives. And this is x, this is y. And guys, here the coordinates are radical 2/2 and -radical 2/2. So when I take the ratio of those two, obviously we know this is sine, this is cosine, right? This is sine, this is cosine. When I take the ratio, I'm going to get -1. So that means the angle is -45. So this equals to, so we have only simplified the tan inverse of -1, so it is still equal to sine of, but this guy we already simplified this using the techniques and methods that we have learned already in my previous videos, which is going to be -pi/4 radians. Now we have to calculate the sine of -pi/4. Guys, to find the sine of -pi/4, basically we don't have to go anywhere. We just actually go back to the same exact point on the unit circle, and the value for that is -radical, because it's the y value, -2/2. So this is the final answer or final value for this expression. So guys, it was not, I just need to make sure, yeah. So guys, this was not too complicated, but then here they were both inverses of each other, and then you had to check if it is in the domain. That worked out all well. Same thing here, but here they were different, right? It's sine, it's tan inverse. You cannot just, they will not just cancel each other out. They are not inverses of each other. So then we realized, hey, can we actually evaluate or find the value for this piece inside the parentheses, like the inner one? And we can see here that we can actually do that, right? So we did that. Finally, we bring it back together, and then using the unit circle, it was not too difficult to finally get the final value for this. Okay, guys, these are some basic, simple calculations or simple examples on the composition of trig functions with their inverses. I will see you in my next video with some more challenging problems on this section. Till then, guys, keep practicing, and I will see you in the next